Here's the solution to homework set number 10 for ECE 341. The first problem is, suppose I sum 10 uniform distributions for A and 8 uniform distributions for B. Find the mean and standard deviation of A and B. Well, for a uniform distribution, so there's A, B, the mean is halfway in the middle. That's for single one. For 10 of them, the means add. So the mean for A will be 30. The variance is the spread, B minus A squared, over 12. Gives you, for single one, 6 squared over 12. For 10 of them, times 10, so the variance is 30. Take the square root to get the standard deviation. Likewise for B, the mean will be 40 and 66.67. For problem 2, find the 90% confidence interval. For that, you go to StatTrack. For 90% in the middle, I want to have 5% tails. So the right tail is 5%. The left tail is 5%, leaving 90% in the middle. The z-score is how far from the mean do you have to go. That's 1.645 standard deviations, called the z-score. So what that tells you is that if I go left 1.645 standard deviations and I go right 1.645 standard deviations, I'll capture 90% of the area. So A will be in the range of 20.99 to 39.01 with a probability of 0.9. For problem 3, that's a single-sided t-test, or single-sided test. I've got my uniform distribution. What's the probability that A is going to be bigger than 40? For that, I can find out how far is 40 from the mean in terms of standard deviations. Again, that's the z-score. So it is 1.82 standard deviations away. From StatTrack, I can find out what's the area of a normal distribution, 1.82 standard deviations out, and that's 3.4%. Problem 5. Suppose I've got two populations. So you could think of it like here's cats and here's dogs. And I'm just going to take the weight and determine, what's the weight of the animal. If my threshold is 35, so A has a mean of 30, B had a mean of 40. If I sit there, take an animal and weigh it, and say if it weighs more than 35 pounds, I'll call it a dog. If it weighs less than 35 pounds, I'll call it a cat. The probability of a false positive, false negative would be it's really a dog, but I call it a cat. It weighed less than 35. That'd be it's actually B, but I called it A. That's a false negative. Apologies to cat lovers out there. And a false positive is it's really a cat, but I called it a dog because it weighed more than 35 pounds, which is a really fat cat. What's the probabilities? Again, that's a z-score. I want to find out how far is 35 from the mean, because what's the area of the tail, in terms of standard deviations. For A, this distance right here is 0.912, so the z-score is 0.912. From StatTrack, that corresponds to a probability of 18%. So this area is 18%. 18% chance it's a cat, and I call it a dog. The other tail is how far is 35 from 40. In terms of standard deviations, this is 0.62 standard deviations away. From StatTrack, that's 27%. So this tail is 27%. 27% chance of a false negative. 27% chance it's a dog, and I call it a cat. Problem 5 is regression. If you go to this website, you can get the weather in Fargo since 1942. I'm taking the 7th column, which is June. If I plot temperature versus year, that's what Fargo's been doing. Do a linear curve fit. That's trending analysis. So what I do is I set up the basis. The basis will be year and 1. That's your B. My constants are A and B. That's A. And the resulting is temperature. So to solve for this, or this is actually June, I'll do the inverse of B transpose B, B transpose Y, or June. That is the least squares curve fit for the data, and you get 0.05 and minus 32. So this says that the temperature is roughly 0.0510 times year minus 32.9, 35.29. Gives you the red line. With that, I can see how much has Fargo warmed up in the last 80 years. Just take the slope times time, 4 degrees. So it is getting warmer. Fargo's 4 degrees warmer on average in June since 1942. Problem 6 is correlation. If it's a hot June, is it going to be a hot July? Well, there you do the correlation coefficients. The covariance is the mean of x times y minus the mean of x times the mean of y. That's the covariance. The correlation is the covariance divided by the standard deviation of x times the standard deviation of y. So June and July are 36% correlated. If it's a hot June, 36% chance it's going to be a hot July. In terms of January and June, there's a 16% correlation. So 16% chance if it's a hot January, it'll be hot June. And that's kind of expected. The further you go out in time, the less the correlation. That's homework set number 10 for ECE 341.